This is a space combat video for those who like their space battles with a bit more realism. In other words, for all you HFY authors who lean towards hard SF, this is one to bookmark for future reference. How would a realistic space battle go down? What would it look like? We're gonna find out today. Okay, so let's just cut through the crap, shall we? If you want to see cool explosions in space, watch any old Star Wars movie or BSG episode. But if you want to know what an actual fleet action would look like, well, buckle up because we're going to talk about kinetic force. TL. DR. Space is big and mostly empty, so it's really easy to see everything. So no stealth, no sneak attacks, only head-on attacks. Battles will be fast-paced and violent, but relatively brief, too. Now brace yourself for some non-intuitive concepts. First, everyone can see you. Second, kinetic force is awesome. Let me expand on that first concept. Everyone can see you. Take a look at this image here. You might think that the ship on the left has the advantage because it's hidden behind an asteroid, right? Wrong. While it might have partial cover from enemy fire, the fact of the matter is that an enemy ship could spot it long before the ship on the right could spot them. Why? Because space is mostly empty. There's nothing to block line of sight unless there's another asteroid or planetoid floating nearby. Even then, ships with good sensors could just go around it. So, don't waste your time writing about stealth fighters in space unless you're planning on giving them cloaking devices. It's not happening otherwise. And even then, sensors can still detect changes in gravity readings and variations in local space-time caused by a cloaking device. In other words, you can cheat all you want, but you're still going to get detected eventually. By the way, if you want to learn more about cloaking devices, stay tuned for our upcoming video on Alcubierre's warp drive. It's fascinating stuff. All right, now let's talk about the second point. Kinetic force is king. Here's a simple rule of thumb. A 100-ton ship traveling at 100 kilometers per second has roughly 50,000 joules of kinetic energy. Double the speed and the impact is 200,000 joules. Quadruple the speed and the impact is 400,000 joules. And finally, if you were to increase the ship's mass to 1,000 tons while keeping its speed at 100 kilometers per second, the impact would equal 500,000 joules. That means that kinetic force can be devastating. At low speeds, a 100-ton ship can punch through the hull of a 1,000-ton ship. However, at high speeds, a 100-ton ship could rip apart a 1,000,000-ton ship. This is why high-speed capital ships are so deadly. They carry a massive amount of kinetic force. A battleship traveling at 1,000 kilometers per second smashes into an enemy carrier at roughly 250 million joules of force. Compare that to a 1,000-ton fighter craft traveling at 1,000 kilometers per second, and you get about 5 million joules. In other words, a high-speed collision between two capital ships could deliver the same amount of damage as 20,000 fighters, which is why capital ships pack such a wallop. Now let's put these two factors together. Since everyone can see you, every captain will know their ship's mass, acceleration, and delta V intimately. Every captain will also know the mass and delta V of their opponent's ship and how many of each type of weapon they have. In other words, every captain will have a full understanding of their opponent's capabilities. Battles will come down to who makes the right decisions based on the relative strengths and weaknesses of their respective fleets. And remember, unlike naval battles in the real world, losing a ship in space isn't going to result in it sinking beneath the waves. It's going to result in a few pieces flying off and burning up in the atmosphere of some faraway planet, leaving the pilot very possibly alive and kicking, though maybe just a little bit charred. So let's imagine a space battle now. Two fleets are approaching each other at high velocities. Both sides can see the other clearly, and both sides know exactly what the other is capable of. So there's no surprise when the first missiles are launched, only immediate response. Each missile traveling at 10 times the speed of sound would take less than 30 seconds to reach its target. So while missile defense systems exist, they're not foolproof. Rather than taking potshots at one another, both fleets will maneuver aggressively, trying to close the distance between them so they can unleash their full firepower. Maneuvers in space aren't like maneuvers on Earth. Aircraft can execute sharp turns, dive, fly backwards, turn around, and do all kinds of crazy things. But space is just different. Forces are spread out, and maneuvering requires a lot of fuel. Once a ship reaches orbit, it doesn't spend much time decelerating and then accelerating again. It's just not efficient. So maneuvers in space are usually executed over minutes or hours, not seconds or minutes. Because of this, ships typically engage at full throttle in straight lines, and they hit hard. The most common engagement pattern will be for two ships to launch all their weapons at once and then crash into each other. You've seen this scene many times in movies, but now imagine it without the laser beams or torpedoes. The weapons we're talking about are solid objects traveling at very high speeds. A fleet engagement might look like a swarm of bees fighting over a hive, except instead of bees, it's ironclad capital ships armed with long-range missiles and short-range kinetic kill vehicles. Imagine these ships colliding, crashing, exploding one by one until only a few remain. But the fight doesn't end there. Those remaining ships will have to repair damage and resupply themselves. Then they'll have to chase down and destroy whatever enemy ships manage to escape. This cycle will repeat itself over and over again until one side or the other is destroyed. Now, of course, this is just one possible model for space combat. Another equally valid model comes from the world of tabletop war games like Eclipse and Star Trek Attack Wing. The idea is that missiles are fired and then dodged. Each ship will expend a small amount of fuel to make evasive maneuvers, making each successive missile harder and harder to hit. Eventually, the firing ship will miss, at which point the two ships will reverse their roles and the dance will begin anew. In this model, battles can go on for days or weeks as each ship slowly bleeds off fuel. But that's a topic for another video. Today, we're sticking with kinetic force is awesome, and everyone can see you. Now, if you want to write about a space battle in your own story, consider the implications of these two factors. Your job as a writer is to take advantage of the audience's lack of knowledge about space. Most people don't know how things would play out in space, so it's up to you to educate them. But don't just tell your readers that kinetic force is awesome. Show them. Depict the violence of a high-speed collision between two capital ships. Let them feel the G-forces as they are slammed against their seats as their ship executes an emergency maneuver to avoid a collision. Don't tell your readers that everyone can see you. Show them. Have your characters watch helplessly as a nuclear missile streaks toward their ship, knowing that there's nothing they can do to stop it. Now, if you're looking for inspiration, check out John M. Ford's The Burning Man or David Weber's Safehold series. Both authors do an excellent job of depicting space battles with a good mix of action and technical detail. And that's it for today. If you enjoyed this video, please leave us a like and comment below with any suggestions you might have for future videos. For instance, should we discuss the pros and cons of nuclear versus railgun weaponry? Or maybe we should talk about the role of artificial gravity in space warfare. Either way, thanks for watching, and we'll see you next time.